And yeah, today we're going to talk a little bit about scaling Ethereum. I think on the talk it says something about L2s, but yeah, talking about scaling Ethereum without shortcuts, which obviously includes layer 1 scaling and layer 2 scaling. If you wanna track the slides, there's a link there. You can watch them as I go along as well. But first, a little bit about who am I? So just for a little background, so I discovered Bitcoin first in 2013. That was my first foray into the crypto space. I was 18 years old in college, and my roommates told me about it. So I was learning how to program, started developing all my trading applications, hooking into Mt. Gox, and very quickly, who here knows what happened to Mt. Gox? Right, I think quite a few knew. So I lost all of those Bitcoins, then lost basically everything I had at that point. Took a step back, and only until 2016 or so I was introduced to Ethereum. And in 2017, I actually attended my first crypto conference, which was Devcon in Cancun, and I attended as a volunteer. And so huge props to all of the volunteers out here today helping out with ETHDay. Super integral, but also a great way to create a community and to be a part of a community and to really dive into the ecosystem. So I attended Devcon 3 as a volunteer, and I was absolutely amazed. I understood very little about what was going on, but I knew what was happening was definitely going to change the world. And so basically since then, I dove into it. I am now the Devcon lead and the Devconnect lead. So this is actually, the first time that we've organized Devconnect. Welcome to an experiment, I would call it. And so yeah, hope you guys are ready for an awesome week. We're super excited to have you here. Big props again to Eleanor and the team for hosting the first ETHDay, the first major event of the week. And we have a lot of cool events lined up for the week as well. So hope you're excited. Maybe see you over at the co-work space later for some social hour. But I'm not a researcher, actually, so I do a lot of community education, both in Latin America, where I live now, and just in general, and that includes a lot of communication or education around layer 2s. So that's what we're going to talk about a little bit today. But first, I think it's important to recap, why are we here, and what do we want to build with Ethereum? So we want a global, credibly neutral system. With a system like that, we can have things like sound money, like Ether. We can have things like a trustworthy place to store and maintain property rights, whether they be digital property rights or representations of physical property rights, which in my mind are NFTs. We can have a platform for coordination among many disparate individuals who are working towards a common goal, which is what I would consider what DAOs are trying to do today. And many more things, like everything from identity to other financial applications and things like that. But in order to have something credibly neutral, we need that thing to be resistant to censorship and uncontrollable by any single entity, no matter how powerful that entity might be. And to have a system like that, we need that platform to be super decentralized, operated by many independent nodes around the world. And the reality of the situation is that's not that easy. And in doing that, in creating a system like that, it's tempting to take shortcuts. And so when we're talking about blockchain scaling, there are a couple tempting shortcuts to take, one of which that is actually really well articulated in Vitalik's blog post here called The Limits to Blockchain Scalability. If you scan this QR code, you can go and check that out and read that later. I would recommend it for all. But essentially, one shortcut that exists in blockchain scaling is sacrificing the ability for regular users to be able to run nodes, to be able to run full nodes. And so when I talk about nodes here, I'm talking about full nodes, which basically means you are downloading incoming blocks to your computer, and you're validating, you're verifying that they are correct. I'm not talking about staking nodes. I'm not talking about the need to actually stake and support the network. I'm talking about being able to run your own full node. And a shortcut that exists that is tempting to take in blockchains is to sacrifice the ability for regular, normal users to be able to run their full nodes. And the way they do that is they increase the block size and they increase the block times. They advertise super fast scaling. They advertise super cheap fees. But in turn, they are sacrificing decentralization. Now, the hard way is to maintain the value that users should be able to run their full nodes. Which requires more advanced techniques. And you cannot just increase the block size and increase the block time, but you could scale while trying to maintain decentralization. So this is the way that we're going to talk about. So great, make it so that average users can run a node. The Ethereum roadmap prioritizes this, and we need to improve it more, to be honest. We need to make it much easier for average users to run a full node, and a lot of the upgrades coming to layer 1 are targeted towards this as well. So what's the problem? The problem is gas is expensive. So the throughput on Ethereum layer 1 is intentionally constrained. So it is intentionally constrained because we want to make sure it's easy for average users to run a full node. So we want to be able, like an average user has an average computer, and we need to be able to create a worldwide system that doesn't require more resources, more computing power than an average user has to run. So we're intentionally constraining the throughput in Ethereum, but what does that mean? That means that it is now expensive to use because a lot of people want their transactions inside of it. And so we run into this problem where layer 1 is expensive because we are not sacrificing decentralization. So that brings us to like the scalability problem. And maybe like more explicitly, why is gas so expensive? If we remember what gas is again, right? Gas is a combination of where block space is available versus demand for that block space from the people that want their transactions. And the problem being a lot of people want to include their transactions on Ethereum, but the space and speed is intentionally restricted to allow average users the ability to run the nodes, so that space that is available becomes much more expensive. So to quickly run through it, I guess, there are two more or less ways to scale a blockchain. There are both scaling via layer 1 and scaling via layer 2. And so on the left, we'll jump into scaling via layer 1 really quick here. And how we will not scale via layer 1 is we will not simply make the blocks bigger, we will not simply make the blocks faster, because then you're jacking up the node requirement for average users, and average users won't be able to run a full node. Here's an unknown other blockchain that exists out there that advertises them being very decentralized, but more than that, super fast. So you can see 2,000 some transactions per second, average cost per transaction, the total transactions that they have processed, and this is on like their front page, like right there, and this is what they want you to know. But what they don't necessarily tell you behind the scenes is like the requirements to run a node. And so to run a node on this network, on this blockchain, you need a CPU with 16 cores in it. They recommend the RAM you have on your node is 256 gigabytes or more. How many people have 256 gigabytes of RAM on their computer they're walking with right now? You know, or maybe at home. And then you have you need not only just that, but you also need networking. So you need an internet service that has at least 300 megabytes per second, and they recommend a gigabit up and down, symmetric. Like that is something that's I think possible but difficult to get in city centers. And for most of the world, especially developing countries, just straight up impossible to get for average people. So one does not simply increase block size and block times to lower transaction fees. How we will scale, however, is trying to maintain true decentralization, maintaining censorship resistance, and trying to keep the power in the hands of individuals. So our plan for layer 1 scalability is complex, and it takes time because we're trying not to take sacrifices. So Vitalik put out a diagram of like one perspective of the roadmap, which is like this community roadmap that's like the Ethereum community has generally agreed upon. And if you want to scan the QR code, it brings you right there to that tweet. But zoomed in a little bit further, we can see we have the merge, the surge, the verge, the purge, the splurge. And so they're kind of goofy names, realistically. But each one of these, the idea being here that each one of these brings separate upgrades to the layer 1 that either increase security or increase decentralization or make it easier, right, to run a full node, or increase like maybe like from an MEV perspective. So they do different things, and each one of them is fairly depth. But if you scan this QR code, you can go check out a lot of resources about each one of these if you're curious. And for those of you who were here for Tim Baco's talk this morning, he dove in a little bit deeper about the layer 1 roadmap. And so maybe you can rewatch that as well. So I'm not going to spend a ton of time on the layer 1 scaling. What I'll talk a little bit more today is layer 2. Because cool, layer 1 upgrades are incoming, but gas is still expensive now. What can I do today to get cheaper fees? So we'll talk a little bit about the second way to scale a blockchain, which is scaling via layer 2s, ZK rollups. So layer 2s, in my mind, are a layer 2 is something that inherits the same security, that shares security with the main chain. And so I would say not all scaling solutions are created equally. I think depending on like the diagram you look at or who you talk to, layer 2s could incorporate different types of scaling solutions. So some would say that side chains are part of the layer 2 scaling. Some would say that like validiums and volitions and these other types of scaling are part of it. But for me, I would say layer 2 is something that inherits shared security. And by that, I mean that it is basically like the validators of the layer 2 system cannot rob your funds or censor you even if they wanted to. And that's the case in sidechains, many sidechains that exist, and other types of scaling solutions. So here we'll talk about layer 2 as being primarily rollups. And diving into a little bit about rollups. So this talk came about because essentially we talked about ETHDay, right? And like we're going to cover a bunch of like high-level things that are happening in Ethereum. And I was like, Ellie, we can't have ETHDay without talking about scaling and without talking about the gas fees and talking about rollups. And so it's a really high-level description, but there's some links here so you can go deeper into learning more about them. But for those of you who maybe haven't heard about rollups before, rollups, the idea with rollups are that they're separate chains outside of Ethereum that move the difficult and costly computation off of layer 1. And so these separate chains, like you basically imagine if we were all on the separate chain, we can make a bunch of transactions among ourselves. And at the end of these transactions, the final state gets submitted back to layer 1. And an important part about layer 2s, or about rollups in particular, is instead of creating its own security, it inherits the security and decentralization benefits that the main chain has, which for Ethereum is fairly great. And if a rollup provider wanted to steal your funds, they couldn't. Because of the crypto economics, or in ZK rollups, the cryptography that exists with these rollups, even the rollup providers couldn't steal their funds if they wanted to. That's not the case with sidechains. That's not the case with alternative layer 1s. And so when we talk about scaling Ethereum through layer 2s, we're really excited. This is why the community is really excited about rollups. And if they stop processing transactions, the rollup providers, or if they want to censor you specifically, there's always an ability to exit back to the main chain, exit back to layer 1. So even if they wanted to steal your funds, to censor you, they run into challenges and they're not able to. And why are they called rollups? Because they essentially roll up many transactions into one final state and submit that back to layer 1. So why use rollups? Well, they're cheaper, there's higher throughput, and they inherit Ethereum's security and decentralization benefits. And they're censorship resistant and secure. The provider cannot rob your funds even if they wanted to. And with other types of scaling solutions like sidechains and other things, you are trusting a different and often weaker set of validators and security assumptions. So here's one example. If you look up there on the right, that's l2fees.info. And you can see that this was maybe taken a few months ago, late last year. And at that time, to swap tokens on Uniswap, it cost $30. On Optimism and Arbitrum and Loopring, it costs $2. And today, that would cost even less because they've optimized even farther. And so quickly about the two types of rollups. So after computing, optimistic rollups and ZK rollups are like the two main types that exist out there in the ecosystem. You've probably heard of them before. Maybe some of you know them very deeply. But for those of you who don't, so optimistic rollups, basically the way they work is after they compute all the transactions, they submit two things back to L1. They submit the final state of those transactions back to layer 1, and they submit a little bit of stake in Ether back to layer 1 as well. This is the rollup provider submitting this. Then there's a contract on L1 that accepts it without knowing whether or not the result of those transactions is actually correct. The contract is an optimist. And so what happens is those funds sit in that contract for 7 days, or whatever amount of time the rollup decides. And in those 7 days, anybody can verify whether or not that final state transition is correct. And if it is not correct, anybody can submit a fraud proof that proves that is not correct. And in that case, If it's indeed not correct, the challenger wins the stake. And if it is correct, then the tokens are freed, and everything works like normal. So that the case in which the fraud proof is submitted and the challenger actually wins is like the odd case out there. Most transactions probably are good. But yeah, that's more or less how optimistic rollups work. ZK rollups work a little differently, where the rollup submits the same final state, except with a cryptographic zero-knowledge proof that the layer 1 contract can verify immediately. The way the zero-knowledge proofs work, you don't actually need to submit a stake or wait for anyone to verify. The contract itself can actually verify whether or not the proof was correct. And so the downside with that is, or the plus side is you don't need to wait 7 days. The downside is it's also quite a bit more complex. So maybe a little bit about pros and cons with the optimistic rollups versus ZK rollups. The pros are the optimistic rollups are available now for everything you can do on layer 1. The con is that if you want to if you want to withdraw your funds to L1, you need to wait. And it depends on the rollup, but sometimes it could be 7 days or it could be shorter. In some perspectives, it's not that bad because a lot of the activity will be moving to rollups in general, and we'll be living in a multi-rollup world potentially soon. On the other hand, ZK rollups, you don't need to wait to withdraw your funds back to layer 1. Because it's proved immediately with cryptography. But the con is that it's a little bit more complicated. And you still cannot copy and paste your Solidity code from layer 1 dApp into a zero-knowledge proof. So they're both working on improving these. Zero-knowledge proofs, for instance, are working on ZK EVMs. Optimistic rollups are working on making things more efficient. And they both have their different pros and cons right now. And I say we're still early. I think most of these launched late last year, I believe. And so, yeah, I'd say we're still early with the rollups, but this is sort of the way that the ecosystem, Ethereum, is moving towards this rollup-centric roadmap. So I think in the future, I think it's very likely that we'll be living in a cross-rollup world where all of the rollups have shared security with Ethereum. And the rollups only need to focus on execution. They can maximize this execution and their efficiency with it. They can start doing parallelization of transactions, and the security is managed by layer 1 the entire time. And the gas costs end up being split across many users, amortized in the case of ZK rollups, possibly also with optimistic rollups as well. And perhaps we'll see the majority of us normal users interacting with Ethereum via rollups, not via layer 1. Having cheap, fast transactions, but still inheriting the same security that Ethereum provides and inheriting the same decentralization benefits that Ethereum provides. So that's what I would say. I'd say a couple key takeaways here are, one, it's important to allow average users to run a node, not just make it possible, but make it super easy for the average lazy user to run a node. 2 is many projects sacrifice that ability for scaling. Be wary of the billion transactions per second or super cheap transaction fees marketing. If an average user can't run a node, in my opinion, is not decentralized enough. And 3, scaling without sacrificing decentralization is hard. There are both layer 1 and layer 2 ways to scale. Real L1 scaling needs advanced techniques. And we're working on those in progress in different upgrades that are coming to Ethereum. And L2 scaling, like rollups, are available now. So if you want cheap, fast transactions while still inheriting the same security of Ethereum, you can use rollups. So for users, use them. For developers, deploy to them, whether it be Optimism, Arbitrum, ZK Sync, StarConnect, Aztec, and many more. And a couple resources that I'll leave you with before departing is L2Beat, which is a great resource for analyzing different rollups that exist out there. Analyzing both the risks and their market share. Then L2 fees for analyzing the different fees for the rollups versus Ethereum. So you can see what it costs versus where. ETHCPS is also interesting to see how much of the transactions per seconds are going, how much of the transactions on Ethereum are going through rollups in comparison to Ethereum mainnets. And just a reminder that we are very early in this entire thing. Rollups just launched. And I do think that we as an ecosystem are we are super excited and excited about rollups in general and layer 2 scaling in general. So I would encourage you all to explore them, start using them, yeah, that's what I would say. So if there's any questions, I don't know if we have time for questions, maybe not, because I think we're a little tight on time here, but I'll be walking around if not, and you can come find me. So I appreciate all of your time, and see you at all the other events throughout the week, throughout Devconnect, and thanks again to Ellie and the team for putting on this amazing event.